Alright, let's look at the practice exam 2, problem number 3. Alright, so cylindrical drum is submerged at the bottom of the pool, 10 meters deep. So I drew a picture in purple, and I placed the x-axis, y-axis so that the center of the cylinder is right at the origin. Alright, so it looks kind of like that. Alright, let's try to find pressure at level, say, yi star. So I'm going to just put level here. So I'm going to call this guy, say, yi star. Alright, at this level, the pressure is going to be, so let's find a pressure. So I'm going to call it the pressure PI. Right, pressure is going to be a water weight density, which is the delta, which is given here, times the depth, maybe called di. Right, so we're talking about a little piece of rectangle right at yi star. So it looks kind of like that. Right, approximating rectangle. Alright, then we want to find the depth of that little piece. Alright, so here's the depths. Alright, so di is going to be, alright, so this is at yi, and the surface of the water is at 7, so it's going to be 7 minus yi star. Right, so this is going to be, so let's see, water density is given to be 9800, and a di is given to be 7 minus yi star. Right, so that will give us the pressure at this level. Right, then if we want to find the hydrostatic force just on this skinny piece, we can find the force. Actually, before that, maybe we should find it just the area of that piece. Right, so the equation of the circle is x squared plus y squared is equal to, radius is 3, so it's a 3 squared. Right, then we can solve this for x, so subtract y squared from both sides. You have x squared is equal to 3 squared would be 9 minus y squared. Then we take the square root of both sides. Then you get x is going to be equal to plus or minus square root of 9 minus y squared. Alright, so you can see that from here to there, so that's the x value. So it's a square root of, actually, maybe, how about this? Alright, so the value here is a positive square root of 9 minus y squared, and the x value there is going to be negative square root of 9 minus yi star squared. So maybe I should do that, my I star squared. Right, so if you want to find the length of this little skinny rectangle, is going to be, so it's from a negative square root of 9 yi star squared to positive square root of 9 minus yi star squared. So it's going to be 2 square root of 9 minus yi star squared. Right, and the width of this is always delta y. Right, so base times height, since it's just a rectangle. So it's going to be 2 square root of 9 minus yi star squared times delta y will give us the area of this skinny piece. Alright, then we can find the hydrostatic force just on that piece. So I'm going to call it Fi. Alright, Fi is just the pressure, Pi, times the area, Ai. Alright, so we just basically multiply these together. So 2 times 9800 is going to be, let's see, there are 2 zeros. Right, 2 times 8 is 16. And 2 times 9 is 18. So it's 19,600. Then there's going to be 7 minus yi star times square root of 9 minus yi star squared, and then we have delta y. Right, so that's the force, hydrostatic force, just on that piece. Right, then what we want to do is we have to cover the entire circle or disc, so we have to add them all up. So the force on the side of the drum is going to be, right, so we have to add them all up. So summation I goes from 1 to n. Then we have all that, so it's a 19,600, and then 7 minus yi star times square root of 9 minus yi star squared delta y. Then we have to take the limit to make it more accurate, right, as n goes to infinity. Alright, then we can turn this into an integral. So this is going to be an integral here, right? Limit sum becomes integral. And you can see that to cover the entire disk, we have to start from -3 and then end at +3. So this goes from -3 to +3. Then you have maybe I'll put the since this is just a constant, I'm going to put let's see, I'm going to just move this guy around. Alright, then I'm going to put the constant right in front. So it's 19,600. Right, then we have to just strip off I and star. So you have a 7 minus y times square root of 9 minus y squared, and the delta y becomes dy. Right, so this is the integral for the hydrostatic pressure on the side of cylindrical drum. Right, that's it. I hope that this was clear.